The key thing with data collection is we collect a GPS location. It's an X and a Y, a latitude, a longitude, and I'll talk about this stuff when I catch up with you later. We can also capture a Z, which is your elevation. Elevation is critical with a lot of modelling and stuff like that later on. So a GPS like this is simply capturing a location, and we can put a tag in that to say, EV1, so Eucalyptus viminalis 1. So any other additional information we attach, and the power of spatial information is the aspatial or non-spatial. So the attribute data that you attach to that. So when you collect your points today, you'll be entering a unique code, what we call a unique identifier. If anyone knows databases, will know this, into the message screen of this. We download this location data, and we can attach the manual data that you record in the field to that, and we can display it up on a map. We can do all sorts of things. We can say, show us all the glider boxes that we used, show us all the ones that were under 3 metres, show us all, and we can have multiple queries. But that's down the mapping end. These are recreational GPSs, $200 each. They're only accurate between 10 and 30 metres, so don't, if your life depends on it, I wouldn't use these things. But they're excellent for what we need. This is about $5,000, and it's basically a microcomputer and a GPS. You can scan barcodes, you can go on the internet, you can pretty much do anything but phone your dead mother, sort of stuff on these. It's all touchscreen as well, so this is how far it's moving, and if you get into one of the agencies, you'll be using these, hopefully, and not those things. These are accurate down to about 4 centimetres globally. And the beauty of collecting global information is you can email it tomorrow to some researcher in the States, and they can put it on a map and they know exactly where you're talking about. And they can cross-compare to later records. So we do this survey today, and the beauty of it is we want to compare it to 6 months' time, 12 months down the track, and further on. We'll have a look at this stuff when we get together for our first workshop. I think we've got 3 days of workshops this year. Middle of the road type thing, recreational Magellan, about $1,000, colour screen, but still pretty crappy with the accuracy. So I'm probably not allowed to say words like that. Again, it's a bit more of a recreational thing, but you can put a unique ID. You can take photos as well. Pleasing a lot. Yeah.
Are you finding that the technology is progressing as quickly as mobile phones? And
it's going so fast.
Is the $5,000 thing getting a bit slow in 2 years' time? Or?
Yeah, well, I'm doing some consulting on the side and mapping, and I've just bought an $8,000 GPS, mad, crazy. Partner's not happy, but it's being superseded already, and that was 6 months ago. Yeah. So I guess the story is don't go and buy any of this stuff because it's going to be out of date. You can hire it. You can go on eBay and get these for $50. If you're just looking at perhaps mapping koala locations, woody weed locations, these are fine. The power is in this. And the beauty of these is that they have an electronic form with drop-down boxes. So there's no paper, it's all on here. The only problem with some of these GPSs, though, they have inherent errors. So you move under a tree, and some of them lose signal to an error that we call multipath. I won't go through all that stuff now, but when you collect a point, you need to walk up to a position and wait for a minute because the satellites actually have to catch up. Because all these are is pretty much like a wristwatch. The satellites are going around up at what a planes fly, 10 Ks, 10,000 metres above the volcano at the moment. You should be interested in that stuff. Most satellites are orbiting from 20 kilometres upwards up to 200, up to 2,000 kilometres above. So they're well away and above, out of range of that. Some of the satellites at the moment take pictures, so they act for the GPS system, the location, but they also have sensors on board to take images like you see here. And most of them can cover the whole Earth in 4 days. They take a picture of every part of the planet in 4 days, which is pretty incredible. So for natural resource management comparative work, we can get a shot. If we're after a particular weed that flowers at the start of the year, we can get a shot there. We can then get another shot 12 months later, and we can map and monitor changes in weed extent, in indigenous veg removal and stuff like that. So the power of this stuff is in the location, the info attached, and the fact we've got fantastic global coverage. That image there does anyone know satellite air photo? I've told you it's satellite, so I can't ask you that, can I? This is what we call the false colour image, and it's in the near infrared. I thought I'd use this as opposed to a normal air photo, just to help you interpret some of the different veg types, plant types, weed types, and I'll explain them when we get further down. But the red colour is photosynthetic growth. It's near infrared, it's what we can't see. Animals can see in near infrared and stuff, we can't. But these sensors up on these satellites can pick this up. So you can imagine farmers that have persistent weed growth. They've got a massive property. They're trying to control a weed that flowers at a particular time of year or only grows when everything else doesn't grow. They can pick it out quite clearly using some of this technology. And certainly there's advanced things you can do. We can actually completely weed map an area. If we know the reflectance colour of one of these objects, we can go down to the ground and actually record it with a spectrophotometer. We can then ask the computer to race around and group all those like pixels together, and we end up with a weed map. And very useful in places like Kosciuszko National Park, where you've got sort of cliffs like this, and, sort of valleys like this that you actually can't get into. So satellite imagery is really useful for broad scale and really targeted natural resource mapping, I guess. Alright, so I'll talk. Are there any questions on that? I've jumped around a little bit to try and pull it all together quickly. I'll just give you, I might as well give you these, so a bit of reading until we next meet.